Okay, we're going to look at the financial math part of this practice control test. And let's just get started. Here we go. A school buys tablets at a total cost of $140,000, but the rate of inflation is 6.1% per annum over the next 4 years. How much is it going to cost to replace them in 4 year time? 4 years time. The compound interest formula is the interest for inflation. P stands for the money that it's worth right now. I is the interest rate, so you go 6.1 divided by 100, 0,061, 4 years. Just put it in your calculator. It's going to cost 177,414 rand and 69 cents to replace those tablets. Then the next question says, an investment earns 7% per annum, but it's compounded semi-annually. What's the effective annual interest rate? And all you do is figure out 1 year worth of interest. 1 year worth of interest. So you go 1 plus 0.07 divided by 2 squared on your calculator. And you'll get a number, take away 1 from it, and you'll get this number. So you don't have to do all this, All you have to do is take 1 year of interest and take away 1, and you'll be looking at the effective interest rate. Should be a little bit bigger than 7%. In fact, it is. It's 7,12. Just move it over 2 places. That's called the effective interest rate. 1 year of interest minus 1. Let's look at the next question. Now, they say a savings account was opened with an initial deposit of $24,000. 18 months later, $7,000 was withdrawn from the account. How much money will be left at the end of 4 years? Well, there's 2 ways of doing it. You could think of, what if I didn't take any money out at all? What if I didn't withdraw that $7,000? Then I'd have $24,000 going for 4 years. But gee, I took away 7,000, and because I took it out after 18 months, there's 30 months of interest I'm going to lose on that 7,000. So that's one way of doing it. 24,000 for 4 years minus 7,000 for 2.5 years after 18 months. I'm not so keen on that. It's not as natural for me. This is the way I would do it. I would take the 24,000 and I'd grow it for 18 months because that's what they said they did. And I'd get a first amount. Then I'd take away 7,000 and then grow it for the 2.5 years left. That's 1.5 years. And 24 plus 6 months, 30 months. Hey, look, I get exactly the same answer. And I find it a little more natural to think of it that way. I can grow the 24,000, then I take away the 7,000, and then I grow that investment for exactly the time that's left. Hey, I get the same answer. Well, that's the way I like to do it. There's more than one way to do it. Now they say there's a car that has a book value of 102,000 and some other money. After 3 years, if it depreciates, it cost 198. But then it depreciates. This is the reducing balance depreciation formula. 1 minus I to the n. This is the value you start with. This is what it depreciates to. 1 minus, it's called reducing balance. So you can just put this in here as I. That would actually be fine. And you're going to solve for 1 minus I to cubed. That's what I would do like that. But the key thing is you've got to divide by 198,000. And because it's cubed, you've got to take the cubed root. So you'll have 1 minus I. You'll have 1 minus this, the interest rate here, equals this weird number. Well, all you do is take away 1 from it. You'll get this number here. And as a decimal, this is what it equals, 0.19. As a decimal, you can write it as r over 100, I guess, because now you multiply it by 100 and you get right to the answer here. 19.64%. But the key thing is you divide by this number, then you take the cubed root, you'll get a number. You have to go 1 minus that number. You see the number comes over here. You have to subtract 1 from it, and you'll get a negative number here. You get this 1 minus r over 100 equals this weird number. Then you have to take away 1 from it, and you're looking at the answer here, this 0.196. That's 19.64%. And that's the little business there, financial maths part.